While descriptive statistics summarize the characteristics of a data set, inferential statistics help you come to conclusions and make predictions based on your data. When you have collected data from a sample, remember we have a sample which is taken from the population, from a bigger population, because in real research, we are not dealing with population, but we are dealing with sample because of some constraints like time, money, resources. So we just get a certain portion of the population and we try to analyze data from the sample and try to, infer it to the whole population. That is why we have inferential statistics. You can use inferential statistics to understand the larger population from which the sample is taken. So inferential statistics like t-test, analysis of variance, regression, Pearson's correlation have two main uses. Okay, number one, is making estimates about populations. Okay, and next is another use of inferential statistics is testing hypotheses to draw conclusions about populations. So we make some assumptions. And in order to test these assumptions, and these are what we call hypotheses, and in order to test these assumptions, okay, we test this hypothesis and draw conclusions about them and apply it to the general population. Okay, but however, we have to make sure that our sample is sufficient enough to represent the population. Okay, now hypothesis testing is an act in statistics whereby an analyst tests an assumption. So hypothesis testing is an act in statistics whereby an analyst tests an assumption regarding a population parameter. The methodology employed by the analyst depends on the nature of the data used and the reason for the analysis. So the kind of statistical test that we use, it depends on what type of data are we processing. Say, for example, are the variables measured in the interval or ratio scale, or the variable measured at the ordinal scale or nominal scale? So it is very important that we should first understand what our variables are and how they are measured. Are they IR, interval ratio data? Are they continuous or discrete? Are they binary or not? So because the statistical test, the preceding statistical test that we will conduct will then be dependent on the type of variable that we are playing or that we are analyzing. So a hypothesis is an educated guess. Why is it educated? Why is it an educated guess? Because we just don't make a hypothesis, state a hypothesis randomly from somewhere or out from, from heaven. No, we base our hypothesis based on related literature. Okay, for example, you claim that there is gender bias in anxiety level, meaning to say there is a difference in anxiety level. Generally, in the population, there is a difference in anxiety level in anxiety among or between the males and the females in the population. And you would be asked, why do you make a claim such as that? Bakit kaya? Why do you claim that? Because then you would say, well, based on previous literature, this is what it says, that there is a gender difference in anxiety. There's difference in anxiety between the male and female. So you have proof for that. And because this is science, we don't just take something, a claim as true or not. Now, because it is science, there needs to be a continuing study to test such claim. And if in the future researches, in the future studies that test that claim, and it is always accepted, that claim is always established or accepted, then that hypothesis is now elevated or promoted to a theory. Okay? And when a theory is always proven to be true because of empirical analysis or empirical testing, because of research, kasi nag-umpisa muna yan from a hypothesis and then a theory, and if a theory is always proven to be true, then it now becomes a law. Okay? Parang ano na yan, nagiging natural law, kagaya sa physics, na the law of gravity, that with all things being constant, we can always predict, sure, that anything that falls from a higher level will go down to a lower level because of gravity. That is a law of gravity, that everything will attract itself towards the earth. So yan. So it is a law. It is no longer a theory, but it is now a law kasi nakikita natin constant siya, palagi siyang na-observe in the population sa phenomenon. So in small studies, in specific single studies, we cannot test theories nor can we test laws kasi generic yun, deductive yun. Okay, ang ano natin is we test single hypothesis. Okay, hypothesis. Okay, so we say it is an educated guess because we start from somewhere. It is from related literature. Okay, so that guess should be clear and precise. It translates the problem statement or research question in a form that is amenable to testing. So actually your hypothesis is just your research problem declared or stated in declarative form. Okay, so pag sinabi, is there a significant difference in anxiety between the male and females, between the males and females? So that is your specific problem. And then you state your hypothesis. You have a problem, then you should have a solution. You should propose a solution. So that is where hypothesis comes in. Okay? So your hypothesis, a hypothesis is stated in declarative form. So if the specific question, inferential question is stated in interrogative form, the hypothesis is stated in declarative form. So magkaano lang sila, magkabaliktad. It's the same thing as your specific inferential problem. Okay? And the hypothesis posits unexpected relationships between variables or expected difference between groups. So hypothesis, a statement of relationship or a statement of difference between groups that are being compared. Okay, and again, it reflects the theory or literature on which they are based. And the hypothesis should be brief and to the point, and it should be testable, meaning to say it should be answered by yes or no. Okay, now hypothesis has two forms. One is null and the other one is alternative. So we have null hypothesis and we have an alternative hypothesis. Alternative hypothesis is also called research hypothesis. Okay, so here we have hypothesis is a premise or claim that we want to test. When you say a null hypothesis, what kind of hypothesis is that? It is a null hypothesis. It is said to be a null hypothesis because it represents no relationship or no difference between groups or variables. It is the null hypothesis is usually the default hypothesis. It is the default hypothesis. It is the benchmark. Okay, it serves as the benchmark at which we make our decision from. Okay, so ito yung null hypothesis. We always assume that the null hypothesis is true unless otherwise proven to be unless proven false. Okay, so we always assume it to be true unless proven false. Just like parang sa courthouse, di ba? Sa courthouse, we always initially believe that the defendant is guilty, that the accused is not guilty. I mean, we initially believe that the accused is not guilty unless otherwise proven to be guilty. Yun. So, palagi tayong, we always assume that the null hypothesis is true unless evidence as otherwise. Okay? So, it is the benchmark ng decision natin. So, for example, this one, there is no relationship between reaction time and problem-solving ability. So this is a null hypothesis. Why is this a null hypothesis? Because of this phrase, no relationship. So, kasi pag sinabing null, nothing. It states that there is no relationship. Okay, another one. There is no difference between the effectiveness of community-based long-term healthcare for older adults and the effectiveness of in-home long-term healthcare for older adults. So here, in the first example, it is testing for relationship. In the second example, it is testing for difference. That means there is a comparison between community-based healthcare and in-home healthcare. Because in researches, we try to establish that there is a difference between the interventions that we are testing, that we are comparing, and if there comes out to be a significant difference, then we can assume that any change on the dependent variable is due to the intervention that we have done. So here, the intervention, the independent variable is the type of healthcare, whether it's community-based or in-home. And what is the dependent variable? Effectiveness. So, ano yung mga indicators natin ng effectiveness? Maybe we can say the well-being of the older adults. Ano ba yun? Yung physical health nila, mental, psychological well-being nila. So, ito yung indicators natin ng effectiveness. So, yon. And here, there is no difference, the third example, there is no difference between the average score in comprehension test in the morning class and the average score in comprehension test in the afternoon class. In this way, we have, in this example, we say that this is a null hypothesis because it states that there is no difference, none. We can see no difference. No statistical significant difference between the morning and the afternoon students in terms of comprehension test. So if you were the student here, if you were the researcher here, what would you do? Maybe In order to test this hypothesis, you would conduct a pre-test. You will randomly select people and then randomly assign them to two conditions or two intervention. One condition would be the control condition, wherein hindi. One condition would be the morning. You would give them a lesson in the morning, and after that, you would give them comprehension test. And then the second group, you would give them a lesson, the same lesson in the afternoon, and afterwards, you would give them comprehension test. And okay, sa pre-test and the post-test, they would be the same. It should be the same, pre-test and post-test. The pre-test, you conduct the pre-test and test if there would be difference in the pre-test scores between the morning and the afternoon classes, because you want to establish that before intervention, there was no difference between the two, that with all other variables being constant, they are the same. These two groups of people are the same in terms of age, in terms of grade level, in terms of IQ perhaps, and they only differ in terms of time of day. Learning material, they are the same. They are just different in terms of time of day, because our independent variable in this particular example is the time of day. Does it affect comprehension level of students? Okay. Sa theory kasi, yung circadian rhythm, it affects also, cognitive ability of people. So, may mga tao talaga who are morning people, and there are people who are evening people. Yun. So we want to test that. So that is a null hypothesis. Okay, in mathematical equation the null hypothesis is written as this. Okay, dito for this null hypothesis. There is no difference between the average score in comprehension test in the morning class and the average score in comprehension test in the afternoon class. The null hypothesis is stated as this: HO, meaning to say zero, null, nothing. Okay? The mu, itong Greek letter na mu, it stands for the mean for the average of the population. Because when we are talking about the sample, ang term natin doon ay S sample siya, or X bar. So mu1, that refers to the population mean of people, of morning people, and the population mean of the afternoon people are equal. Kaya you can see there is an equal sign. So, bakit population mean? Why population mean? Because this is hypothesis testing. We are making an inference that whatever observation that we see is true to the population. And we say that in the population, the null hypothesis is claiming that in the population, there really is no difference between the morning and the afternoon people. Kaya ang null hypothesis, palaging mu yan. Ina-assume niya yung mu, yung population average. Okay? The purpose of the null hypothesis, it is the starting point or benchmark against which the actual outcomes of a study can be measured. Until you prove that there is a difference, you have to assume that there is no difference. It provides, the null hypothesis provides a benchmark against which observed outcomes can be compared to see if these differences are due to other factors. Okay, you never prove an alternative hypothesis. You can only reject a null hypothesis or fail to reject a null hypothesis. Okay. In technical terms, actually, the correct term, statistical term here is fail to reject. That means accept the null hypothesis. So there are only two outcomes in our testing of a hypothesis. Either we reject the null hypothesis or accept the null hypothesis. So we are testing the null hypothesis actually, not the alternative hypothesis. However, whatever decision we make on the null hypothesis is carried over, the opposite of that decision is carried over to the alternative hypothesis. So either we reject a null hypothesis or we fail to reject the null hypothesis. So I just say this as accepting the null hypothesis para mas madaling intindihin. Kasi most of the time students have a hard time understanding what does fail to reject mean. Okay, actually it only means accepting the null hypothesis. Okay, you can only reject a null hypothesis or fail to reject the null hypothesis. You can never really directly prove your alternative hypothesis. You can only reject a null hypothesis or fail to reject the null hypothesis, which means it can be true. Okay, which means it can be true, but you are not totally sure. So researcher really wants to reject the null hypothesis. This is our aim. We want to reject the null hypothesis because that is the closest that we can get to proving that the alternative hypothesis is true. By rejecting the null hypothesis, this is the closest that we can get to prove that our alternative hypothesis is really true. In other words, you can prove that a given treatment caused a change in outcomes. Okay, but you can show that that conclusion is valid by showing that the opposite hypothesis, that is, the null hypothesis, is highly improbable given your data. Okay, so yun. Yun ang concept doon. So, another type of hypothesis is your research hypothesis or alternative hypothesis. This is the alternative hypothesis. It represents presence of relationship or difference between groups or variables. It involves the claim to be tested. So if the null hypothesis says that there is no significant relationship, the research or alternative hypothesis says otherwise. Okay? Yung kabaliktaran ng sinasabi niya, it says there is a significant relationship between reaction time and problem-solving ability. There is a significant difference between the effectiveness of community-based long-term healthcare for older adults and the effectiveness of in-home long-term healthcare for older adults. There is a significant difference between the average score in comprehension test in the morning class and the average score in comprehension test in the afternoon class. So this is a research or alternative hypothesis. Why is that? Because you will take note that here, well, nawala na, the word no is deleted, but it is replaced by a significant relationship, a significant difference. Okay? So, yun po siya, mga kapatid. So, that is your research or alternative hypothesis. Your research or alternative hypothesis is the opposite claim to the null hypothesis. Okay, so mathematically, how do we state the the research hypothesis. The research hypothesis has two types. May dalawang klase yan. There is what we call the non-directional and the directional hypothesis. The non-directional hypothesis reflects difference between the two groups, but the direction of difference is not specified, just like this one. There is a significant difference, or there is a difference between the average score in comprehension test in the morning class and the average score in the comprehension test in the afternoon class. So makita ninyo that that hypothesis 1, which represents our research hypothesis, it says here the mean sub 1, that refers to the mean of the sample, of your actual sample, because you can only make observations of your sample, okay, of what data you have there, okay, not the whole population. So the mean sub 1 is not equal to the mean sub 2. So ito yung ibig sabihin, not equal. So ibig sabihin, there is difference. If it is not equal, then there is difference. There is a significant difference between the two. Kaya the symbol there is not equal. And if the difference is simply stated, okay, it simply states significant difference, and there is no specification as to whether it is higher or lower, then we say that that research hypothesis is a two-tailed hypothesis or non-directional hypothesis. Wala siyang pakialam whether it is the morning or the afternoon class that has the higher or lower score, for as long as there is a difference between the two. That is non-directional. Now, there is another hypothesis, and this is what we call directional or one-tailed test or one-tailed hypothesis. It reflects difference between the two groups, and the direction of difference is specified. For example, this one, the average score in comprehension test in the morning class is significantly higher. Okay, take note, the morning class is significantly higher than the average score in comprehension test in the afternoon class. So, kita natin dito, hypothesis 1 is equal to, okay, the mean sub 1 is not equal to or less than the mean sub 2. May slash dyan. Ibig sabihin, ito is not equal or not less than. Or, to state it in another way, another mathematical equation which has the same meaning as this one, we say, the mean of the morning group is greater than the mean of significantly higher than the mean of the afternoon group. Okay, the mean of the morning class is significantly higher than the mean or the average score of the afternoon class. They are just the same. So it's not equal, it's not less than, but it should be higher. So there is a specification there for a one-tailed or directional test. I need participation in here. Okay, I have here a list of 6 hypotheses, and I would like you to tell me whether this hypothesis is null or research hypothesis or alternative hypothesis. And what type of hypothesis is this? Is this directional or non-directional? Okay. 1. Late night snacking makes no significant difference on weight gain. Is that a null hypothesis or alternative hypothesis?
Null hypothesis, no?
Null hypothesis.
It is, yeah, that's right. It is a null hypothesis. Now, is it directional or non-directional?
Non-directional.
Yeah, it is non-directional. Tama. Okay, if you were the researcher of this topic, how do you think would you do this? Paano mo gagawin ang research in order to test that claim that late night snacking makes no significant difference on weight gain?
Doc, actual process po ba of testing or proving the hypothesis po?
Oo, yung research, paano mo gagawin to?
Okay po. Try ko lang po, Doc. I think I can have a control group po of people who will have late night snacks, and then for a period of time, I will observe kung mag-gain sila ng weight or not.
Okay, yes. Malapit ka na dyan. Sino pa ang may idea? This is a simple methodology that you can do in order to test that hypothesis that late night snacking makes no significant difference on weight gain. So first is you form two groups. Okay, what are these? Control group, and we have experimental group. Okay, now this control group, they would have no snacks, no night snacks, and the experimental group will have with night snacks. Okay, next, you will give them, okay, you have to make sure that all things are constant, meaning to say approximately constant. Let's say in terms of initial weight, they should be the same. That is why in terms of weight, body weight, because, okay, again, what do you think is the independent variable in this hypothesis? And what is the dependent variable?
Doc,
Yes.
I think the independent is yung snack po and the dependent is yung weight.
Okay, very good. That's good. Tama. You're right, Marshall. So you will first have a pre-test, meaning to say pre-test on both groups. You have to weigh them. Tingnan mo yung ano nila, body weight, yung BMI nila siguro. In this case, we have to pray that these two groups are the same. Okay, there is no significant difference. During the pretest, we have to make sure that these two groups are not significantly different in terms of body weight or BMI. Okay, yung control and experimental group, initially, they are not different in terms of body weight. Okay, kasi we have to establish that it is only the intervention that made a difference between the two. So they have to be the same in terms of activity. They have to be the same in terms of food intake, the quality or the kind of food. So i-control natin yan in both the control and experimental group. They should all be the same in terms of, let's say, ano pa ba yung ano natin, age, activity, daily activities na they are engaged in, they should be the same. Then you do an intervention. So walang intervention dito. Ito, my intervention. What is our intervention here? Night snack. Bibigyan natin sa experimental group, we'll give them night snack. In the other group, no night snack. We have to monitor that. Then after, let's say, 2 months of this intervention, we make a post-test again. Post-test. What is this post-test? We measure their BMI. And in the post-test, if we are able to establish that there is difference in BMI, in body mass index, okay, between the control group, the group with no night snacks, and the experimental group, the group with night snacks, then we can safely assume, we can safely conclude, not assume, kundi conclude na this time. We can now make a safe conclusion based on our data that, okay, based on our statistical testing, there is a significant difference in BMI between the control and experimental group, and therefore that difference is due to the intervention that we have introduced to our group. And that intervention is night snacking. Lalo na pag nakita natin na mas tumaas ang body mass index. Pero, however, ito kasi wala tayong there is no presumption of whether of which group should have a higher or lower score. We are only concerned about looking at significant difference. So now we can safely conclude that late night snacking affects BMI of our samples. And therefore, we can conclude that this claim is true not only to our sample, but also to the population. And we can say that if we have enough or sufficient number of samples to represent our population, and that the samples are randomly chosen. Okay, next case. Giving rewards for good behaviors in class significantly increases the likelihood of good behaviors to be repeated. Okay, first question. What is the independent variable and the dependent variable in this study?
Doc, I think it's
Doc.
the rewards, Doc. The independent. And the behavior po is your dependent variable.
Okay, very good. So the independent variable is the reward, and the dependent variable is the frequency of good behavior. That's right. Now, what kind of hypothesis is this? Is this a null hypothesis or research hypothesis?
Research hypothesis, Doc.
Research hypothesis.
Okay, very good. Now, what kind of research hypothesis? Is this a directional hypothesis or a non-directional hypothesis?
Directional po.
Directional po, Doc.
What gives you a clue that it is a directional hypothesis?
With the line significantly increases.
Yes, that's right. Significantly increases. It significantly increases. So there is an assumption that one group should have higher score than the other group. Okay. Now, how about the third one? Using different shades of lipstick among teachers does not significantly affect language imitation in preschool kids. Now, what is the independent variable and the dependent variable in this study?
Independent, ma'am, shades of lipstick, and then dependent will be the language imitation.
Okay, very good. Now, what kind of hypothesis is this? Is this a null hypothesis or an alternative hypothesis?
Null, Doc.
Null hypothesis. Null po, Doc. It's
Oh,
What gives you a clue that it is a null hypothesis?
Does
not
not
significantly
affect language imitation.
Okay, very good. Now, how about, is it a directional or non-directional hypothesis?
Non-directional.
non-directional po, Doc.
Okay, it is non-directional. Now, you're getting it. Okay, anuhan na natin. Homeschooled children significantly yield lower score. homeschooled children significantly yield lower score in socialization measures than regular school children. Now, is this a null hypothesis or an alternative hypothesis?
Alternative, Doc.
Alternative po.
Research, yes po, Doc.
Alternative.
Alternative
Now,
research
what type
hypothesis.
of alternative hypothesis? Is this directional or non-directional?
Directional.
Directional po.
It is directional.
Directional.
Yes. What gives you an idea that it is a directional hypothesis?
Significantly yield lower
Lower
score.
score.
Oh yeah, the word lower. Yeah, diba? Tama? The word lower gives you a hint that it is
Yes,
a
po, Doc.
directional hypothesis. Okay? Now, how about emotional maturity of youth significantly differ according to their perceived parenting style of their parents? Now, what is the independent variable and the dependent variable in this study?
Parenting style
Depend-
is the independent.
Independent, Doc, is
Style.
style, and then the dependent is this emotional po, maturity.
Emotional maturity.
Okay, very good, very good. Now, what kind of hypothesis is this? Is this a null hypothesis or alternative hypothesis?
Alternative, Doc. Alternative po, Doc.
Alternative po.
Okay, very good. Now, how about, is this directional or non-directional?
Directional.
Directional po, Doc.
Non-directional.
Directional.
Non-directional.
Non-directional.
Directional,
It is
significantly.
non-directional. It is two-tailed. It is non-directional. Now, how about masculinity among boys is significantly related to paternal presence and involvement. Yeah, it is an alternative. Is it one-tailed or two-tailed?
It's directional po, Doc. I know.
Non-directional.
Non-directional po, Doc.
Non-directional.
Yeah, it is two-tailed. It is non-directional. Yes, very good. Nakuha niyo na. Okay, so you got the concept already. So you got the concept between the difference between the null and the alternative hypothesis, between the directional and the non-directional, between the one-tailed and the two-tailed hypothesis. Okay, now, di ba ang sabi ko, our default hypothesis is, ang default hypothesis natin is the null hypothesis kasi we can never prove an alternative hypothesis. We can only make action on the null hypothesis, whether we reject it or fail to reject it. Okay? Diba? So anytime you reject a null hypothesis, there is a probability that you made a mistake. Okay? So dalawa yung pwedeng maging action natin sa null hypothesis. Whether we accept the null hypothesis or fail to reject the null hypothesis. So, in order para mas madali makagrasp yung mga neurons natin, gumamit ako ng term. Technically, statistical technicalities, the proper term would be, politically correct term would be, fail to reject. Okay, based on the true nature of the null hypothesis. If the null hypothesis is really true, and we have accepted the null hypothesis, kung totoo yung null hypothesis, tapos we have accepted, and then we accepted the null hypothesis, then you are doing a great job. Kaya nakasmiley siya. Okay, you accepted when it is true. That is correct. That is good job. However, if the null hypothesis is really true, and you have rejected the null hypothesis, you have rejected the null hypothesis, then you are committing what we call type 1 error. Okay? We have rejected the null hypothesis when there really is no difference. And that is what we call alpha. that error is, the probability of making a type 1 error is what we call alpha. Ito, this is a Greek symbol, alpha. It is what we call sa atin false positive. Parang sa COVID test, di ba? Sa RT-PCR, we undergo swab testing and it comes out to be positive. So, i-quarantine ka na ngayon, i-isolate ka na kasi positive ka daw for COVID. Only to find out, wala ka namang symptoms. Hindi naman pala totoo that you are positive for COVID. Iyon ang tinatawag na false positive. Kunwari, happy na kayong mag-asawa kasi ang lumabas doon sa pregnancy test kit, buntis ka pala. Wow! Thank you, Lord. Pero after a while of waiting, hindi naman lumalaki ang tummy mo. After ultrasound, hindi naman pala totoo. It was a false positive. Okay? So, it is a type 1 error. And when you commit that probability of making a type 1 error is what we call alpha. Now, in research, hindi naman talaga tayo nagsasabi na dapat 100% accurate, walang error talaga. Okay, no, we don't make a claim on that. We allow for some error. And what is our boundary? Okay, we allow a probability of making a type 1 error of an alpha of 0.01. It means that out of 100%, 0.05. Normally, this is a cut-off, arbitrarily chosen cut-off value for alpha. It is 0.05 probability value. So when you convert that to percentage, it becomes 5%. Now, 1 minus alpha is what we call confidence level. Your confidence level. So 1 minus the alpha of 0.05, you will have a confidence level of 95. Yun. So that is your alpha level. That is your boundary line. That you can only take an error of up to 0.05 or 5%. Okay, now, when the null hypothesis is really false, okay, doon sa taas, the null hypothesis is really true. But now, what if the null hypothesis is really false? And you accepted a false hypothesis. Dito sa quadrant na to. Ito dito sa cell na to. You accepted a false null hypothesis. So what kind of error is that? That kind of error is what we call type 2 error. It is incorrectly accepting the null hypothesis when it is false. And it is what we call the false negative or beta. When you fail to reject the null hypothesis, when you should have rejected the null hypothesis, that probability of making a type 2 error is what we call beta. So itong tinatawag na false negative. Kunwari, nagpa-swab test ka and it comes out of the RT-PCR result that you don't have COVID. But actually, you have symptoms. Pero dun sa result ng RT-PCR, wala ka daw COVID. So that is what we call false negative. After further testing, based on the symptoms, we can presume that you really have COVID. But then the RT-PCR is making a false negative result. Okay? And what kind of error is that? It is what we call type 2 error. The probability of making type 2 error is what we call beta, and we want to avoid that. And in order to avoid that, we have to increase our power. Ano yon? You go back to the G power, di ba? In your research, in order to increase the power of your research, you have to increase yung sample size mo. Nandun yun sa G power, di ba? Pag nagko-compute sa G power. And the normal acceptable value for power is 0.80. 0.80 and above power. This is statistical power. Ito yung acceptable value, the standard acceptable power. So kung mas mataas, mas better. Now, if you have rejected the null hypothesis, which is really false, ito ha, in this quadrant here, if you have rejected, you have rejected the null hypothesis, which is really false. Okay, false yung null hypothesis and you have rejected that, then you are doing a good job. You rejected the null hypothesis when there really are differences between groups. So that is what we call power. Okay, tawag dyan, you have a good power in your research. Okay, so power, it is the percentage chance that you will be able to reject the null hypothesis if it is really false. The probability of not making a type 2 error. Cutoff for differentiating between low and high power would be roughly 0.8 or 80%. So having a beta less than 20% is good. So before you even start the study, you could do power calculations and potentially avoid conducting a study with low power. Power increases if you increase sample size, increase effect size, that is the actual difference between groups, and increasing precision. Okay? So yan siya. Andito. So 1 minus alpha is equal to confidence level. And 1 minus confidence level is alpha. 1 minus beta is power, statistical power, and 1 minus power is beta. Now, we look at the p-value. What do you mean by p-value? The p-value is the probability value of your test statistics. If your p-value is less than or equal to the alpha, we reject the null hypothesis. Okay? We reject the null hypothesis and fail to reject the alternative hypothesis. Okay? Our aim as a researcher, if we want to prove our hypothesis, we want this. Gusto natin to. The p-value to be less than or equal to the alpha. Now, if our p-value is greater than the alpha, we accept our null hypothesis. So, significance. Ano ba yung the concept of significance? The significance is or alpha level. Significance or alpha level. This is the risk associated with not being 100% confident that what you observe in a research is not due to the IV or treatment or what was being tested. So ito yung alpha level. So you have a certain boundary, kagaya nito, do not cross. So we allow only a certain margin for error in our estimation, and if it goes beyond that, pag sumobra siya dyan sa 0.05, then we are already committing a type 1 error. Okay? We are committing a type 1 error. So what will set this boundary is the alpha level. That is, let's say, and it is arbitrary. Kunwari, depende kasi yun sa type of research. Normally, if it is educational research, we give a conventional of 0.05. Now, if it is a medical research, and it is life risking, the research is life risking, we can set our alpha level at 0.001 or point as in very minimal talaga. Okay, it is a selected cutoff point that determines whether we consider a p-value as acceptably high or low. If p-value is lower than alpha, then we conclude there is a statistical significant difference between groups or statistically significant relationship between variables. Okay, for example, ito na lang, no? My husband is faithful to me. That is your hypothesis, and you want to test that. So you formulate two kinds of hypotheses, the null and alternative hypothesis. So how would you state the alternative hypothesis then in this kind of example? Larry Ann. What should be your alternative hypothesis? Is not faithful dito pala. Null hypothesis. What would be your alternative hypothesis?
The opposite, Doc. My husband is faithful to me.
Yeah. Husband is faithful to me. Okay, so yan ang hypothesis mo. So, then you would have to set some standards. At what level can you say that that claim is true or not? Okay, so you have to set some standards. So you set, my standard would be an alpha of 0.05. That means I give myself a 5% chance of committing an error that hypothesis is not true. Okay? Now, beyond that, then I would say that my hypothesis is not true. It's not correct. So, now, ang gagawin mo, you now make some research. Okay? Out of 100% of the time na sa lahat ng mga ginawa ng mister mo, and then you try to count, let's say 5%. Kung sumobra sa 5% ang mga kasalanan na ginawa niya out of 100%, then you can say, talaga nga naman na hindi faithful ang asawa ko. Okay? So, sasabihin natin, may test statistic kang gagawin. May test statistic ka, tapos dun sa test statistic mo, lumabas, your p-value is equal to 0.028. Now, how would you do your decision? For your claim to be statistically significant, the p-value should be equal to or less than the alpha level to be statistically significant. Now, you compare your p-value with the alpha. You make now a comparison. Is this p-value less than the alpha level? Is 0.028 greater than 0.05? So your p-value is less than the alpha value. Now, since our decision rule is that p-value should be less than or equal to the alpha to be statistically significant, so we go back to our null hypothesis. We reject this and we accept the alternative hypothesis. Therefore, you now make a conclusion. Therefore, based on the observed data, my husband is faithful to me. Ano yung p-value? P is less than 0.05. Yan siya. Sa practical example, that is how you do hypothesis testing. Okay? So, first, ano yung unang gagawin mo? You state the null hypothesis. State the hypothesis, the null and the alternative. You set your alpha, then conduct the statistical test, and make decisions based on your p-value. The same thing rin sa normality ng distribution. It was also hypothesis testing. Diba? Ang sabi doon, ang null hypothesis says, the distribution, doon sa descriptive statistics, the distribution is not significantly different from a normal distribution. Ganun ang ginagawa ni Shapiro-Wilk. Okay. The distribution, the data distribution of your data set is not significantly different from a normal distribution. Now, your alternative hypothesis would say the data distribution is significantly different from a normal distribution. Now you set your alpha. So what is your boundary? Okay, that you can allow yourself to commit a type 1 error. So I give 0.05.
0.05.
Yan. Now, and then you do statistical test. Anong ginawa mong test? Shapiro-Wilk. Sinabi mo, Shapiro-Wilk. Or based on, sabihin natin, Z value. On Z value, Z skewness. Z value of skewness. Tiningnan mo doon. And then, after statistical test, maglalabas si Shapiro-Wilk or Z skewness ng p-value. So, lumabas yung p-value mo na, kunwari, nilabas niya 0.032. Okay. So, ngayon, based on this p-value, now you make your conclusion. P-value is 0.032 against an alpha of 0.05. The decision rule, the decision rule is p-value should be less than or equal to. So therefore, what shall I do with this null hypothesis? Anong gagawin mo sa null hypothesis if this is your p-value? Shall you reject the null hypothesis or accept the null hypothesis?
Reject.
We reject this, accept the alternative. Meaning to say, your distribution is not normal. Okay? Now, how about this one? If your p-value is equal to 0.086. 0.086 against 0.05. So what is your decision on the null hypothesis?
Accept
again,
the hypothesis.
Why? What is the decision rule?
Because
again,
the value po is greater than the alpha 0.5.
Yes, our decision rule is the p-value should be equal to or less than the alpha level for us to reject the null hypothesis. And since this one, 0.08 is greater than alpha level of 0.05, then therefore we accept this and reject the alternative hypothesis. So therefore we can conclude that the data distribution is normal. Okay, is normal. It is not different from the normal distribution. Kasi ganito yun eh, ginawa ni, ang ginagawa doon sa testing for normality, nag-overlay siya. Kunwari, this is, diba doon sa, this is how it looks like for a normal curve. Now, pag lumabas, based on the Shapiro-Wilk will determine whether your actual, this dotted line here, the dotted line, this is your actual data. And this solid line here is your normal overlay. Ito yung pinaka-pattern. This is the standard for a normal distribution. So it is checking whether your actual data is significantly different from the normal distribution. Now, when it detects based on its based on a statistical test, when it detects that it is significantly different from, it significantly deviates from the normal curve, then it will say, no, it is not normal. It is not normal. And therefore, we reject the null and accept the alternative hypothesis. And since dito kasi lumabas na the p-value is, nasaan na yun? Dito, sa 0.08, the p-value is greater than the alpha. So, the data is normal. Hindi natin ma-reject ang null hypothesis kasi sinasabi niya pareho lang siya. Our observed data or actual data is just the same or not different from the normal overlay. So that is hypothesis testing. I hope these things are clear. So again, the steps in hypothesis testing is first, you state the two hypotheses, the null and alternative hypothesis. Next is you make an analysis plan which outlines how the data will be evaluated. Are you going to do an experiment? Will you make an intervention and try to see what will happen to the dependent variable? Or are you just making a survey research? And then third step is to carry out the plan and physically analyze the sample data. This is now the stage wherein you will perform the statistical test, whether you would be using t-test or Pearson's correlation or whatever, based on your objective, if you are testing for difference or if you are testing for relationship or association. And the fourth and final step in hypothesis testing is to make decision on your hypothesis, whether to reject or to accept your null hypothesis, given your data. Okay, so that's it. That is hypothesis testing. Do you have any question on this topic, guys?